Good morning, everyone, and welcome to the 2021 SLL LightBytes online series. My name is Ruth Kelly-Waskett. I'm President-elect of the SLL, and I'll chair today's session. Before introducing the speakers, I'm just going to run through a couple of housekeeping notes. If you're experiencing any difficulty in hearing or seeing today's webinar, we recommend leaving the session and logging back in. And we also recommend using Google Chrome as your browser. Following today's presentation and discussion, there will be an interactive Q&A session, so please feel free to post questions using the chat function during the presentations. We will aim to answer as many questions as we can within the time, and if there are any unanswered questions, we'll get back to you afterwards and aim to provide a response after the event. I would encourage all of you to join the live sessions if possible and take part in the interactive Q&A. But if you're unable to join the live sessions, you will receive a link to access the recordings from each session on demand. Also, just to note on the questions, if you could please indicate who your question is directed, to which speaker it's directed, that would be really helpful. If you'd like more information about the Society of Light and Lighting, please visit the website www.sll.org.uk or contact sll@cibse.org. So the theme of this year's LightBytes online series is "You Can Have It All: Minimum Energy, Minimum Resource, Maximum Comfort." And this is the second session of the four-part series, exploring how we can approach lighting and sustainability, considering manufacturing, design, installation, maintenance, and waste. This morning, we're joined by three expert speakers from our sponsors in partnership: Helen Looms from Trilux Group, Steve Shackleton from Fagerhult UK, and Tim Bowes from Whitecroft Lighting. So our first speaker this morning is Helen Looms. Helen worked for Trilux Group with a variety of roles, works for Trilux Group with a variety of roles, including marketing strategy and innovations. She's deeply involved in the Trilux Academy, both coordinating at an international level and heading up the UK Academy. This gives her a great understanding of current topics within our industry. Helen has over 30 years experience in the lighting industry since her early years in a photometric laboratory. She is Vice President of the Society of Light and Lighting, as well as being involved with the BSI and the ISO, supporting global standards and communication on human-centric lighting. It's over to you, Helen.
Thank you, Ruth, and hello from me. I'm delighted to be here. Let's see if this is going to work. No. Okay. Right, hopefully you can all see my screen now. Talking about minimum resource, we know resources are such a relevant topic at the moment, but it is a complex issue and not all solutions are straightforward. And I would like to tell you about some research that we have been involved in, which looks at the future of luminaire design. ReproLight is a research project funded over the last 4 years by the European Community. And within this project, we, Trilux, are working with several other partners, and our key R&D activity was to look at the sustainability and circular economy of our luminaires. We analysed the details of all the small components that are part of our most popular luminaire. And as you can see, we've got a lot of metal and also plastic, not only for the optical systems, but also for insulation. And then there are wires and electronic components in the control gear and on the LED board itself. The embodied carbon or energy consumption of each component was quantified. The first stage of the life cycle is the production stage, and we generate certain environmental burdens for the luminaire, using energy to produce the luminaire and also the materials that we use. And this was all analysed. We also accounted for the material mining process and the transportation to the Trilux facilities. The obvious opportunities to improve in this step are to use as little material as possible and to use recycled instead of virgin materials. The steel and copper in the luminaire already contained some recycled elements, but we also wanted to design long-lasting luminaires so that the production process isn't repeated too often. So we focused on improved product design that saves the materials, and especially the most precious materials. We achieved a reduction of 61% of the ADP element content. This is the abiotic depletion potential of elements, and it measures the increased extraction of resources which are now becoming very rare on Earth and leading to a depletion of our natural mineral reserves. We saw that the LED modules have the major contribution in two ways. First, the LEDs were replaced by ones which do not have a gold bond wire, because the gold contained in the standard LEDs is a large proportion of the ADP total. And secondly, the LED module got slimmer, so we need less copper and less materials for the board itself. The new LED modules are also more efficient, so we increased the efficacy from 157 lumens per watt to 179 lumens per watt. The second phase of the product life cycle is the use phase, where we mainly use electricity to operate the luminaire, and it's by far the largest energy contributor at 99% compared to only 1% for the energy used in the production phase. For the material side, we do have some additional consumption, as we need material to generate the electricity, and this is the 26% which comes on top of the production materials. The biggest change we could make would be to decrease the energy used in the use phase, because this is so large, and not only by upgrading the LEDs, but also by taking light management systems into account, where you could easily save 30 to 50% of the energy used. And this phase raises some interesting questions. What happens if the luminaire fails? Should we exchange the failing component, maybe the control gear or the LED module, or do we have to dispose of the complete luminaire and replace it with a new one? Do we want to have luminaires that are maintenance-free, or do we want some components which can be exchanged regularly, like lamps in earlier times? And this is the third detail I want to talk about: exchangeable LED modules, replacing the module if it fails instead of the complete luminaire. Now, when we actually looked at the after-sales data of Trilux, we saw that only 1% of the luminaires are expected to fail within their nominal lifetime, and the largest percentage is due to the control gear. The LED modules account for less than a quarter of all failures, that is 1/4 of 1%. Looking at an example of an industrial hall with 369 luminaires, because of the 1% failure rate, we assume that 4 will fail. 3 because of the LED control gear, and just 1 because of the module. On the left-hand side of the diagrams is a non-exchangeable module. On the right side, an exchangeable one. However, now you have to change the design of the luminaire a little bit. For example, we have to account for some additional components, connectors, in the luminaire which have extra ADP elements, and therefore the problem escalates, because now these extra connectors are needed for all 400 luminaires, just to have the ability to exchange the LED module in one instance. Where you have a non-exchangeable LED module, you have a much lower contribution to the ADP elements. This is because the extra energy usage of just 0.4% for the additional connectors in the design change is larger than the savings you have in the production of one non-exchangeable luminaire. So in total, you end up with a very small negative extra. Looking at it in a more pictorial way, you can see what a small occurrence this is. Is it justified to adapt all of the luminaires to have the benefit in one case. Maybe it would be more expedient to just buy an extra luminaire at the start of the project. And if you have a large project, this is easier to accept, but the equation changes if this is a small project. To summarize the total savings we made in the ReProLight project, on the left diagram, you see again the environmental impact of the benchmark luminaire. The left column is energy and the right one, material. And you can see the environmental impact of the next generation luminaire, including the use of light management system, with light energy savings of 38% and material savings expressed in these ADP elements of 55%, which really is considerable progress. So the successful steps towards sustainability was the improved product design, reduction in precious materials, mainly in the electronic components, an efficiency upgrade for the LED module, and the use of a light management system. We tried some other steps. We had discussions about longer use time and the exchangeable LED modules, but in this case, they didn't prove useful. And I have to say, it might be different in other applications or other luminaires. So once we'd thought out that very well thought out first use, we then move on to the end proportion of the product life cycle, either reuse, refurbish, or recycle. But we also have to consider why we want to replace existing lighting. It's rarely because the product is failing. Usually a refurbishment is implemented along with other interior changes. It could be fashion or wanting to upgrade to more efficient products. So the best solution is obviously to reuse the luminaires, and we will try to find a market for second-hand luminaires. This might have to be a community initiative, but Trilux will also start some research here, and I know there are lots of discussions going on around this particular phase of the life cycle. And we are being encouraged by legislation. However, I am concerned. Some of the blanket rules might not always be the most sustainable route, given the research that I've just shown you. We have the single lighting regulation coming in this year, which means that all LED modules must be replaceable. And I've just shown that it's not always the most sustainable answer. So I'll hand back to you, Ruth, and see what everybody has to say about it.
Thanks very much, Helen. That was really interesting. Thank you. So I'm going to, rather than take questions for Helen now, we're going to take all the questions at the end. So I'm going to move on now to our second speaker this morning. Our next speaker is Steve Shackleton. Steve is Technical Applications Manager for Fagerhult UK and has spent over 40 years in the lighting industry, initially as a lighting designer and latterly in management roles encompassing lighting design, systems design, marketing, technical and sales, both in the UK and Europe. It's all yours, Steve.
Thank you, Ruth, and good morning, everybody. And I'm very pleased to be able to contribute to this season of LightBytes. Let me just minimize myself there for a second. There we go. Okay. So, yeah, to start, let me just quote Fagerhult's Chief Sustainability Officer. He recently said that our greatest opportunity to make a difference in lighting is in reducing the energy consumption from our luminaires in use, and hence the focus on energy in the first LightBytes. However, he did go on to say that in the future, as green energy use grows, the materials we use will become the biggest issue for us to focus on, as it will in the construction industry in general, which apparently accounts for about 60% of UK waste. And to see where lighting fits in, I'd like to just look at three areas, starting firstly with optics, the design of which could help pave the way, I think, to a more efficient use of resources. And I'll start with a very familiar lighting product, the recessed downlight. This has been the luminaire of choice for numerous building areas worldwide for many years. And from an outward appearance perspective, it's a product type that's remained largely unchanged. The example shown here is an entirely typical design, and like many others, it's evolved from compact fluorescent through to LED. Early versions in particular relied very heavily on the reflector to collect and redirect light out of the luminaire from the compact lamp. Later iterations, using more directional and less optically complex LEDs, relied a little less on the reflector, but it did remain a fundamental part of the optical system. But the latest version is a bit different. The fitting looks conventional in outward appearance, but it uses a lens based on the classic Fresnel design. Other pronunciations of that name are available. That type of lens was originally used in lighthouses from the 1800s. And what this does in the downlight is give a precisely controlled beam of light, which by design almost entirely bypasses the reflector with only a small proportion of the light produced, actually providing the excuse me, lit aesthetic effect. Now that might seem largely irrelevant, but the fewer light control surfaces, the higher the efficiency. And imagine the situation with a conventional downlight where after a period of time you get dust and dirt collected on the reflector. These contaminants reduce the efficiency of that part of the light output and need to be taken into account at scheme design stage. However, in the new approach, the reflector is simply an aesthetic attachment. It can be shiny, matte, white, black, or indeed any colour. It's simply a decorative surface and can be less resource hungry than optical reflectors with specialist technical finishes. Over time, the reflector will likely become dusty or dirty, but this will have no meaningful bearing on the light output of the fitting, hence helping us minimise the number of products required. And of course, in terms of minimising resources used, there's no better way than to have fewer luminaires manufactured, delivered and installed in the first place. So, in fundamental appearance terms, the downlight I've talked about is one example where luminaire designs have not changed as much as I might have expected as we shifted to LEDs. Many luminaires look and feel similar to previous iterations with similar sizes and form factors. Now, some of that is down to practicalities, like filling a 600 square hole in the suspended ceiling, for example, but maybe one other reason has been the use of conventionally designed luminaire optics. Lenses in particular become widely used in LED luminaires, allowing precise beam shapes to be produced to suit many different applications. But the lenses themselves can still be quite bulky despite the miniaturization potential, but maybe technology can help. On the left is a greatly magnified 0.5 millimeter thick foil, and this is precision embossed with 200,000 minute lenses for each LED. The lenses are pitched at less than 1/1,000,000th of a meter and can be manufactured to produce but more or less any light distribution with a high degree of precision. When combined with some of the newest generation LEDs, which might be only 1 millimeter or so square, we begin to see opportunities to dramatically reduce the resources used in constructing luminaires. As this example shows, it's entirely possible to shrink luminaires beyond which we might have thought previously possible. In this case, a linear lighting product with similar light output characteristics to conventional size designs has shrunk to the cross section of a pencil. And it's not hard to imagine the effect on resources used, which in this case has reduced by up to 94% compared to conventional luminaires doing the same job in the same application. So where there are people, we need lighting, of course, and that lighting needs to be sufficiently densely distributed to achieve our expected lighting quality. So the only other metric to reduce the use of resources is to fundamentally change the design of luminaires. Smaller luminaires, in this case tiny, require the use of far less materials, excuse me, of much lower weight, requiring less packaging, less transportation burden, and I think amply illustrates the potential for new technologies to reduce the resources in lighting. So my final subject in this section is not so much about luminaire optics, but about the positioning of luminaires to achieve desired effects. It's been said that architects in the UK have traditionally not specified lighting, but that this is changing quickly with the advent of LEDs, as lighting is able to be integrated into their designs. I'm not entirely sure if this change has taken the world by storm yet, but we are certainly seeing trends in some applications towards integrated lighting. And here are a couple of examples from the retail sector. Retail spaces were conventionally lit from afar, from a distance, often using high ceiling mounted luminaires to provide the required background lighting, with the desired highlighting of merchandise achieved via punchy spotlights. But that's a rather blunt and probably inefficient lighting tool, projecting light over quite large distances. And the alternative, unlocked by LED, is to position luminaires closer to the surfaces being lit. And in this example, that means building lighting into retail displays. Now, LEDs are incredibly flexible light sources, allowing luminaires to have different shapes, sizes, and form factors that can be integrated into building any elements to follow the architecture, or simply to blend the lighting seamlessly into the finishes in the space. Now, whilst these two examples are from the retail sector, there is potential to minimize resources used in many different lighting applications simply by placing lighting closer to or even integrated into the surfaces or the objects being lit, and hence using less lumens, less energy, and fewer materials. So the next time we consider washing a surface with light from a distance, perhaps think about lighting from much closer or from within the surface instead. So we've looked at a little bit about the design of optics, and I'd now like to consider some wider elements of luminaire design and start off with a rather negative, sadly, anecdote. This is the luminaire above my head, which I've used as an ad hoc test bed for integral gear LED lamps. These are bog standard GU10s. And after no more than 1,000 hours run, one has failed completely, the cheapest one. One has inexplicably dimmed to about 1/3 light output, that's the most expensive one, and the third appears to be lasting well. Now, ignoring the massive disappointment that LED lamp producers can't seem to make long life LEDs last long, from a resource perspective, it is far better to have products that endure. A recent EU report highlighted this by saying that extending the life of domestic appliance toasters across Europe by 10% would net a saving of 4,000 tonnes of CO2 and prevent 60 tonnes of waste per annum. So moving on from the LED lamps, let's look at a couple of examples in exterior lighting where the design and quality of luminaires can pay dividends, just like more reliable toasters. Post-top lanterns in the past generally made use of HID lamps which needed to be rapidly changed when they failed, at the risk of leaving a dark area in the scheme, potentially compromising safety. Now, as some of this lighting has been gradually upgraded to LED in recent times, the lanterns used have sometimes been designed using arrays of LEDs aimed at different points to fill the beam that creates the area light distribution, as illustrated on the left here. Now, this can work well, but of course, a distinct gap can be left in the output if an individual LED were to fail, which again could compromise safety, often requiring the entire luminaire to be replaced. A different approach shown on the right is to have every LED in the luminaire light exactly the same area, so that if an individual LED failure occurs, no gap appears in the light distribution. The effect is simply the equivalent of a slight dimming of the output, which is far less likely to cause an insurmountable problem. Whilst we'd hope that LEDs achieve their expected life, individual chip failures do occur, but in the case of this type of overlaid optic, the effect in practice can often be tolerated. Excuse me. Now, post-top and indeed all outdoor luminaires have a particularly hard life, with housings subject to often rapid, extreme and recurring changes in ambient conditions, including the heating and cooling effect as the luminaires operate. These changes can lead to significant pressure differences inside to outside of housings, which can cause seals and gaskets to fail, quickly reducing performance and compromising longevity. Now, for maximum integrity and longevity, this issue has to be addressed, and some products make use of small, purpose-designed breather glands to help solve the problem. These glands often incorporate materials more normally associated with outdoor all-weather clothing and are built into the housing, allowing air and gases to pass. But they resist liquids and other contaminants, but allow moisture, vapor, which might otherwise collect as condensation in the luminaire, to pass. But most importantly, these also help equalize pressure to protect the gaskets, which are precision engineered and critical parts of any sealed luminaire housing and have a particularly hard time. Not only are they attacked by the elements and pressure changes, but they can also be easily damaged by overzealous tightening of fixings and fasteners, from which there's often no going back. The solution is to carefully design the housing to precisely control and limit compression of the gaskets, ensuring that however enthusiastically a fixing is tightened, the gasket can only be compressed to its optimum designed level and no more, giving reliable, consistent performance over time. Now, at some point, at extended intervals, of course, for well-designed products, all luminaires will require to be open for maintenance, and any luminaire used in arduous environments is prone to corrosion, and this can be especially problematic where screw fixings are used to connect parts. Galvanic corrosion, or spontaneous metal-to-metal fusion, a fascinating subject called cold welding, could go on for hours about that, can render fixings, threads, and subsequently the whole luminaire housing useless in a short period of time unless properly addressed. Various techniques were previously used to try to mitigate the issue with varying degrees of success, but today, technology from other sectors, mainly the automotive sector, can help solve the problem. Fixing hardware can be treated with a thin, permanent, impregnated polymer coat, and this reduces friction during tightening of the fixings for a better fit, but crucially, also creates a non-metallic barrier between metals, eliminating the risk of galvanic corrosion or cold welding. Now, this technology has been borrowed from other industries, but can, I think, be usefully used in lighting to maximise the durability and service life of outdoor, in fact, and all products, helping reduce resources used, just like the toaster example that we saw from the beginning. So, my final subject is under the heading of data. And I think this may well be the greatest influence we can have in lighting, in minimising the resources used in lighting and buildings, and that's via the collection and intelligent use of data. Once lighting products become intelligently connected and interoperable, we can send information like dimming and switching commands, but additionally, we can also receive information and gather data. And wherever there are people, there is lighting. And by its very nature, lighting is one of the most densely distributed elements in environments where there are a lot of people. And this potentially makes for an ideal platform to collect information about what is going on in a space. Now, we should differentiate here between lighting, that is luminaires, and many current generation control systems, which often separate luminaires and sensors for reasons perhaps of cost of hardware and ease of integration. In many cases, the potential to gather meaningful data from these networks might be limited because the network is not sufficiently granular, with sensors often being used to control large banks of luminaires over significant areas. Luminaire networks, on the other hand, have the perfect technical infrastructure, like a power supply, and the required density and distribution for sensors that are able to capture the necessary granularity of data. Luminaires can't be spaced too far apart, or lighting quality begins to suffer. So the numerous distribution of lighting points in many spaces is one reason why lighting is often referred to as the backbone of IoT, the Internet of Things. Now, data collected by lighting is not something new. We currently collect data from lighting systems, mainly about light levels, occupancy, and energy consumption. But until now, we've probably not done much with that information beyond immediate control requirements in the area in question, like dimming and switching in response to daylight and occupancy. But data can be valuable in many ways for use by municipalities, building owners, facility managers, and tenants, who could all use the information harvested to facilitate their work and make more efficient use of resources. And in buildings, one of the most exciting developments could be data acquired related to user occupancy. A fine mesh of sensors positioned in every luminaire would give access to real-time information on space usage, and that could drive decisions like where to place coffee machines, for example, or operational decisions like where to deploy cleaning staff. Over time, sufficiently granular, high-quality data would give insights into the use of space that might previously have been missing, and this is where we see the really big potential. Where buildings have previously been sized to accommodate all inside-based employees of a business all at once, detailed and continuously collected data could precisely map space usage throughout the building. This data would allow the square meterage of office space to be optimized with no padding, no excess energy consuming luminaires or other services, and indeed no built structure, all optimized for the actual use of the space rather than simply calculated for a given number of employees. Potentially, over time, that could, like for like, lead to us building smaller buildings than we might otherwise have done. So I'll repeat what I said at the beginning. The UK construction industry accounts for approximately 60% of UK waste. Lighting controls, and especially the data that we can harvest, could potentially unlock the biggest opportunity to reduce the resources used across this huge sector. Powerful stuff, I think. So that's me. Thank you. Thanks for your attention. I'll hand you back over to Ruth.
Thanks very much, Steve. That was there were some really intriguing ideas there, and there's lots of questions coming in for you and Helen now. So we'll have a chance to discuss those shortly. So our final speaker this morning is Tim Bowes. Tim is head of lighting application at Whitecroft Lighting and has been involved in the lighting industry for over 18 years with experience in lighting design, product development and training. Tim is actively involved with the lighting industry. He's vice chair of the LIA Technical Committee and was a member of the task group who wrote the recently published SLL Lighting Guide to Hospitals and Healthcare Buildings. He's also now an advisor for the light concept for WELL. So I'll hand over to you now, Tim.
That's great. Thank you very much, Ruth. Thank you, everybody, and good morning. Thank you for your time. Yes, I'm keen to just finish off. Sorry, 1 second. This last session looking at minimum resource. And I'm going to talk around circular lighting in the built environment. So this is a topic that some of you may be aware that Whitecroft have been sort of actively working on for the last 18 months, 2 years. I'm just going to run through, how it might change the way we design products, the way we specify products, and what we need to be thinking about to ensure we deliver, the most effective performance going forward around thinking about resource using the circular economy principles. And I think the importance around moving on from operational carbon is growing, and certainly we're seeing more and more people asking, requesting us to give data around the impact and how we're designing our products, both from an embodied carbon point of view and also from a circular point of view as well. And I think what the circular economy looks to really try and deliver more than maybe perhaps just thinking about embodied carbon and life cycle analysis and environmental product declarations is it really looks to challenge the climate emergency in the wider aspect. We have to clearly think about operational carbon and embedded carbon with greenhouse gas emissions. Because we manufacture things, we mine things, we get hold of resources, and that has a large embodied carbon impact. So we need to challenge how we go about sourcing those materials and designing our products if we're going to drive down to lowest carbon solutions and get to zero carbon, not just in operation, but in the whole of the life cycle of a building. And actually, we've got to go beyond just carbon and really start thinking about our resources. So, the UN Environment Programme 2016 said we're going to triple the amount of primary materials we're going to extract, and that's going to have a challenge on cost of those materials, a wider environmental impact, social impact as well in what we're doing, and or is it even sustainable to do that? Are we going to put when we run out of materials, or certainly accessing materials in a sustainable way? And there's another thing called Earth Overshoot Day, which is something some of you may be familiar with, which is the point every year that we consume the amount of materials that the Earth can provide us in a sustainable way. And last year it was August the 22nd. It was later last year because of COVID. But again, they have similar figures. We're going to need 2 to 3 times the amount of material by 2050 if we're going to carry on the life cycle in the way that we consume today. And the final thing you also need to try and manage and challenge, and already touched on by Helen and Steve, is waste. 60% of total UK waste is generated from construction, demolition, and excavation. So what can we do with the way we design our products and the way we specify products to manage and challenge both the initial impacts of production, then the longer term requirements around resources and within waste? And certainly the circular economy is one way we can look to address that in a more sustainable way. And this is the source from the Ellen MacArthur Foundation, where the circular economy moves us on from thinking about a linear approach where we take items out of the ground, we manufacture it, we consume it, and then we throw it away, this take, make, waste approach that we have, where we lose the value, both, I guess, financially for one, but also from a resource point of view, by the fact we waste it, and then we then start again and go and source new materials and redesign our products and all the impact that can have. And the circular economy looks to address this differently. It looks to design out waste and pollution, both around carbon emissions and material extraction and waste ultimately in the future. It then looks about keeping products and materials in their use for as long as possible. So we need to think about delivering high quality, long life solutions that can enable future proofing of those products. And then finally, the regeneration of natural systems. Now, whilst within lighting, maybe we don't use biodegradable or biological components that can become fuel for nature. We need to think of ways we can design products and create services and platforms that enable the regeneration of products within our market, based on what they call a technical nutrient. And I'll come back to these at the end of the presentation. But I'm just going to work through each of the 3 different stages now. And as part of the design out waste and pollution section, I will also talk about cradle to cradle, which is a metric and an important way of being able to understand and deliver sort of third-party certification and assurance that what we're providing to the market is circular in its approach. That third-party verification and the requirement around minimizing the risk of greenwashing for clients, of course, becomes more important in what we do. And so if you look at the designing out waste and pollution section first from that model, the circular economy, now how do we start thinking about designing differently in what we do? Obviously, we need to start thinking about how we produce our products in the first place. We need to be thinking about the energy that we use within the production. So can we use renewable energy and responsible offsetting, where that may be required in the shorter term to deliver a balance of the social, economic and environmental value within production? We need to be thinking about the transport impact, both from our supply chain, can we work with local suppliers to minimize that impact, or and the transporting elements from our site to to the site where the project is to be installed, and then what's the impacts around that and the wider production impact. We also need to be thinking about waste. How would we do to manage our waste? And I guess that sits at 3 levels. That's both with the waste with which we supply to site within the packaging. Can we provide renewable, reusable packaging, for example, as a way to minimize waste for site and the pressure that puts on projects? We need to be thinking about the way we design our products in the first place, and maybe offcuts we have, for example, end caps. Now, can we start looking at maybe using 3D printing additive manufacturing processes that minimize the amount of resources that we use in the first place? And finally, the waste, of course, comes from other waste that we have from both that may go into landfill or to be burnt, but also for water waste, and ensure we're managing the risk around water, the impact that can have on the wider social impact of what we do. And of course, that's not just the production from us as the lighting manufacturer, that then needs to come through our supply chain. And again, we need to understand what our supply chain are doing to minimize their impact as well from a carbon point of view and from a pollution point of view, and how they're managing their waste management as well. We also need to think about material reduction, again, something touched on by Helen and Steve previously. And if we take the 600 by 600 flat panel, do we, whilst we specify it maybe from efficiency, from a functional, maybe from an aesthetic point of view, I guess there's a debate to be had around that. But if we think about it purely from materials, how often do we challenge the materials that go into our products? And if you look at a flat panel, it has the equivalent of 102 plastic bottles of plastic in there. Now, virgin material needed for quality and efficiency of the product, but that has to be mined, produced, manufactured, shipped to sites, and ultimately disposed at the end of life, when typically these flat panels are one fit items. But we can design traditional products to fit with the integration of the space today in the 600 by 600 and reduce that amount of plastic from 102, the example here, down to 34. Reduction of nearly 70% in the amount of plastic that's had to be mined, manufactured, produced in the first place, taking that weight from 2.4 down to about 0.8 kilograms of material needed. And if you take that into a school, example where you may have 600 plus recessed luminaires, so that's the equivalent of about 41,000 plastic bottles of material that's been saved. So really thinking about that long term, so that initial waste and pollution potential that could be done within products. If we can start to design products that are more modular in their design, that enable upgradability, that enable future proofing, that enable the facility to replace not just the light source and the driver that maybe we talk about today, but actually all the components, because things get broken, as we can harness future energy improvements, that whilst yes, that improvement may be shortening or becoming less around efficiency, it's still going through that process. So if we design products in a way that enable modularity, suddenly that product doesn't become a one-life product, in that 10-year cycle of replacements. We can deliver products at 20, 30, 40 years and really start to create a real difference in the wider impact around the waste that is produced from lighting. And of course, as part of that material reduction and modular design and starting to understand a lot more about our products, we can start to innovate around materials. We can start to look to use biodegradable materials. We can maybe look to challenge ourselves around the type of products and components that maybe have a larger impact from an environmental point of view. So for example, with drivers, typically we talk about 50,000 hour, 100,000 hour driver lifetime. What is it we would have to do to deliver 30, 40, 50 years of lifetime within a driver to give that proper product a true long extension of lifetime? And if we can't deliver the whole driver at 30, 40, 50 years, what is the part of the driver that fails, that we know fails, that we can then maybe design it in a different way? That means we could replace that component and create the longevity of the performance and minimize the waste into the future that will be caused by a failure or an upgrade on a product. And of course, a lot of this is only really possible through transparency of information, transparency of production, transparency of the materials used, transparency of the future of that product and what can be done going forward. And as I mentioned briefly before, transparency information is really important within this type of environment, because people want to have the reassurance and the confirmation that what they're providing, what they're putting into their spaces, is accurate and true in what they're doing. And what we've done at Whitecroft is we've looked at deliver that evidence of circularity in what we do with our production using the Cradle to Cradle Institute. So the Cradle to Cradle is a certified not-for-profit organisation that is globally recognized, that is a measurement of the safer, more sustainable products made for the circular economy. And we see this cradle-to-cradle reference within the WELL standard, within material health, and also within LEED, again around material responsibility. And they will assess products and businesses looking at the full circularity side of things, but what's also really interesting is they look at the wider social impact around the production of products and materials. And what they do is they look at 5 different categories, and these categories are based on version 3.1. Version 4 was published a couple of weeks ago, actually, but this presentation 3.1, but they still have the 5 categories named slightly differently, but the general sort of idea is still there. And across these 5 categories, they assess products, and both the products and the way the product is designed. So if you take the first one, the one on the left, is material health. And it's not just about how the product is designed, but also really looks at the materials that are used and the chemicals that are, and making sure they're as safe as possible for humans and the environment. And it's done through inventory, it's done through assessing, it's done through optimizing material chemistry. So they have a set of banned materials that we cannot use within products. So we have to work with our supply chain to really understand what those materials are. So it's not just, is it plastic, is it metal, and putting a carbon impact on there. It's what type of plastic are we using, what's the paint finish, what are the chemicals used within that paint finish to again minimize the risk and impacts on our health and on the wider environmental health. So really starting to think about the social element beyond that. They then look at material reutilization, how we can aim to eliminate the concept of waste by helping to ensure products remain in a perpetual cycle of use and reuse for one product use cycle to the next. So thinking about that future-proofing of a product so it can have that second, third, fourth life, or at least the components within that product where possible can have that second, third, fourth life going forward. And what bits cannot be, we understand what we need to do to replace that to reinvigorate some other elements of that product. And they then start looking into the production and the wider sort of value within that production. So they look at the use of renewable energy to ensure products are manufactured using renewable energy so that the impact of climate changing greenhouse gases due to manufacture of the products is reduced or eliminated. Now, if we are looking to offset, ensuring we are offsetting responsibly with the right level of either environmental or social offsetting that we can do to deliver a more sustainable solution going forward. They look at water stewardship to ensure water is recognised as a valuable resource, watersheds are protected, and clean water is available to all people and all other organisms. Then finally, they look at social fairness. They look about what are we doing to ensure minimise the risk around slavery, around fair pay, around socially responsible manufacturing and procurement of components. What do we do with our own business, both to support our own employees, but also the wider community, the wider business, the wider society that we are based in going forward. And you get across those 5 categories, you get a scoring of basic, bronze, silver, gold, or platinum. Then each is rated individually, and then your overall certification level becomes the lowest reference for that product. So this is the first product we at Wycroft developed. We had a bronze for material health. I can assure you that just getting to bronze was a real challenge and was a real success for us. And when we started off on this journey, they weren't convinced that we would be able to get that product up to even to bronze on material health. Almost we'd have to remove the electronics from that certification, but we worked with our supply chain to deliver that material health message. Reutilization of gold within this removable replaceable cartridge elements. And then we then started to understand our business better within the renewable energy, about doing that responsibly, water stewardship, social fairness. And we're already working on the next set of products and driving all of those values up to a high level where possible, so we can get this continual development and understanding of how our business is performing going forward. And we can start to create a wider environmental, social, considered approach to how we design our products and how we sort of operate within our local community as well. So it gives a really nice, transparent approach to design, and we've seen customers really value this additional sort of certification of not just saying the product is circular or green or environmentally conscious, but having the evidence that somebody else has got that third-party certification. So a really interesting approach to delivering sustainable, environmentally conscious design. But of course, we've got to go beyond just products, so we can deliver the most environmentally conscious products, deliver circular products into the market. But how do we make sure that the user can deliver that effectively throughout its use and then that end of life position? Because what we know that in reality, things change. People have an upgrade every 10 years, 15 years of their system, or they want to harness new technology or efficiency improvements that may come through. They may want to change the outputs as the space may change from an office to a meeting room or to a breakout space. So they may want to change color temperature, the visual appearance of the space, and the architectural integration. So we need to enable that products can be flexible enough to deliver that future proofing of a product, to enable the client to start to understand not just the environmental benefit of not throwing that product away and buying a new product, but create also the social value and the environmental value and significance that can bring. And of course, part of that, both from a functional point of view, then moves through to the maintenance. So we need to make sure, yes, clearly we are delivering long life systems that provide reliable components and reliable parts that enable, the minimizing of that maintenance in the first place. But where we do need to provide maintenance on a product, we can easily access all of those spares and components. We can get hold of it using standard tools, making sure we haven't glued components together, and make sure we have access to spares. Now, not just the LEDs and the drivers, but other things get broken, either accidentally or deliberately. Things get vandalized or damaged. So how do we make sure that we can ensure that the customer can access that, enhance that, and get that enhancement going forward? And of course, this is where I think tapping on what Steve was talking about around system monitoring starts to come in here. And actually the system monitoring starts to come really nice around, almost we can start to understand how our products are performing in the market. Through apps and cloud-based systems, we can start to understand the positive impact around facilities management. We can start to understand operational hours, LED output degradation, emergency testing, any failures that start to come through these systems and performance, to enable us to be able to maintain and keep those products at their highest value, and from a light quality point of view and from a material point of view, to enable them to be reused again and again and again. And then finally, this regeneration of natural systems that is the third part of that, sort of the three pillars based on the Ellen MacArthur Foundation. And of course, ideally, we want to use biological materials, but what they also acknowledge within the built environment maybe is we have a thing called technical nutrients that mean we have to create a different way, perhaps, of creating this regeneration. And I've already spoke about the maintenance elements of this hierarchy of reuse, but if I look at these other three elements here, maybe there's still a bit of work to do around this, but how do we start to enable products to be reused or redistributed in the future? How do we enable people to refurbish, remanufacture, to enable future-proofing efficiency improvements that we can gain? There may be a decision why people change products, and how do we enable recycling into the future? So we need to create greater partnerships. We need to start enabling people to understand that we will support that product in the market within its operation, but also we can take it back, and that we can then enable that reuse and redistribution either by ourselves to take it back and reuse it, or actually through a second-hand third party will know what to do with that component or product, understand its performance to enable that reuse and redistribution to happen. Again, for the same refurbishment, to delivering products that enable refurbishments, both within the application today, but also maybe for other people to do that as well. And enable, finally, if we really have to, enable the recycling. So how do we do that? We need to make sure we're dividing and delivering almost material passports, greater transparency of information, providing the LDT file so somebody can go and update that, provide a fresh design, understanding life data, understanding the Revit model, data sheets, spares list, installation leaflets, material data, what can be recycled, what can't be recycled, who's responsible for elements that cannot be recycled into the future. So the client can adapt and adjust and ensure that product has that future benefit and value going forward, to give it the best chance of ultimately not ending up in landfill and ending up being disposed of into the future. Because actually that value may not be with a client who has it today, but that value may be there for somebody else to harness that going forward as well. So just to finish off and conclude before I pass back to Ruth. So circularity is really about a way of delivering positive sustainability impacts. It doesn't just look at the impact today that maybe environmental product decorations do. It tries to divide a platform and a system that enables a future proofing of the spaces and the environments that we're lighting and creating. It does rely on transparency of information. It relies on the reassurance that what's been done up front is genuine and true and is circular, but making sure that people have access to those components or information they need to enable that through life utility to perform effectively and the regeneration to happen as well. It will change the way we design and specify products, I think, going forward, and we've all sort of mentioned that in what we're doing. I think most importantly, it goes beyond product design. We can deliver the most circular products to the market with the most environmentally conscious approach, but if we cannot make sure that it's used effectively and enables the regeneration, that value may well still be lost. So I'll pass back to Ruth, and thank you very much for your time.
Thanks, Tim. That was really fantastic. I still can't believe that there are more than 100 plastic bottles in a 600 by 600, or at least in some products.
Yeah.
It's quite amazing. Yeah, we're going to now take some questions from the audience. Thanks a million to those of you who have posted questions. If you just bear with me, I'm trying to maximize the window where I've got my questions lined up. So the first question that I'm going to address is one for you, Helen, and it came from Peter Thorns. Peter asks, the use of lighting controls can be optimized by using additional luminaires, effective zoning. For example, how does the need for additional luminaires balance against better savings from more granular control strategies? So I guess the question is about how control strategies can be used. So it's not just about optimizing the number of luminaires, but then how you control them.
I think there's two aspects here. I think just by using control systems within a normal luminaire design and scheme design shouldn't need extra luminaires, because you're actually doing the luminaire when there's nobody there or when the daylight is present. So it's exactly the same number of luminaires. You're just reducing the output when it's not needed. I think maybe what he's referring to is when you want to make a more focused design, applying more light where the task area is, to give people the option to have higher levels of light, which is what the new EN 12464 is calling for. Now, if you are putting more lighting in a zone where you know there is going to be a particular task or activity, you know more about the project. Therefore, you also probably know more about where you can use less lighting. So we're talking about the surrounding area and the background area, where we're allowed to reduce the illumination compared to the task area. So it's all about a balance, using more light where you need it and less where you don't. And controls enable us to do that much easier. So I think it is about knowing the project. And I get criticized a lot for proposing these ideas when very often you don't know what the office layout's going to be. You don't know where stuff's going to actually end up. But I think that's something that we as a lighting industry need to really push with the construction industry, so that we get more information earlier on in the design stage, and we're involved much more with maybe the fit out stage. Put less in at Cat A, put more in at fit out, so that we know what the use is going to be. I really think good lighting design, efficient use of materials, and ultimately energy saving all comes from knowing what the building is going to be used for and where the light is needed. And that's the biggest thing that's wrong with our building industry, that we do all these designs before we have that information.
Yeah, I couldn't agree more, Helen. I mean, you and I have talked a lot about this issue, and the fact that that model of tenure, where you build a building and you don't know ultimately who the user is going to be, and it really does pose a great challenge to us all in our drive for sustainability. But thanks a million for that. So I've got a question here for Steve. This is also from Peter Thorns. Thanks, Peter, for all your questions. So Peter asks, what's the trade-off between how small we can make luminaires compared with the general preference to see the light source? We like to know where the light comes from. It helps to give context.
Yeah, good question, Peter. Hello. Yeah, I think if you shrink a luminaire down to the size of a pencil, then what you have to do is the light source is reduced in size, but the light output's the same, so the brightness increases, and that can cause glare. But as Peter says, it's good to see where light comes from. So I think there's a balance to be struck. A light fitting like that, I think, would benefit from having some inherent brightness to it. Of course, what you've got to try and do is engineer it so you're reducing the glare, reducing the UGR value, which that particular product does quite effectively. But to my mind, it's better if you have a product like that that's set against a lit background. So maybe it's set in an installation that's a combined DID type system. But yeah, there is a balance to be struck, and you know, we could, I guess, go smaller and smaller and smaller, but it might not be the best route to go down at the end of the day. And it's still important to retain some brightness in the luminaire. We don't want to go down that route of the old Cat2 solutions that we had in the 80s and 90s, which caused all sorts of problems. But it's, yeah, it's an interesting, challenging area, I would say.
By DID, you mean direct indirect?
Sorry,
yes.
direct indirect.
Yeah.
Yes.
Yeah. I mean, I think, yeah, I suppose my view would be that it depends on the context, because there are definitely some applications where it would be important to see the light source or where the light's coming from, and then there might be other more architectural applications where perhaps you're almost trying to trick the users into not knowing where the light's coming from. So I guess it depends very much. But thanks for that. So I've got one here for you, Tim, from Nigel Monaghan. He says, can you see lighting as a service gaining traction for customers? This simplifies the actions that they need to take.
Yeah, it's interesting, lighting as a service. There's some talk about it in the industry. I think we have to be careful about what it is we're wanting to do with that. I think, you know, so lighting as a service, essentially, the manufacturer keeps ownership of the product. I think it can be circular in its approach if the product is designed, I think, in a circular way. I think if you don't design the product in the way that is circular, and ultimately we just take it back and we, take the flat panel, for example. If we still design a product that has that amount of material in it, we take it back and we dispose of it, you know, we've still lost the value. We still need to design products in a way that enable upgradability, so we can harness, you know, if we are going to be lighting a service, we can harness the future value of that product. We can refurb it, replace the components that need replacing, dispose of the products components that may need, through our supply chain responsibly, and then we can deliver the product that can have a second, third, fourth life. So I think we have to just be careful with lighting as a service, whether it's being used from a procurement advantage and benefits for the clients, or whether it's being delivered for a circular point of view. And I think that, yeah, that's for us still to define. And I guess there is the wider cost. You know, does it work out financially beneficial for the clients as well? I think is another. You know, I haven't got enough detail around that aspect of it.
Do any of the other panelists want to comment on that? I know, Helen, you've spoken about lighting as a service before.
Yeah, I think it gets even more complicated than just straightforward lighting. You have to be very involved with the project, and you have to know the ultimate aims of the project. One that we've been involved with was when we knew the building was going to be torn down after 15 years. So we had a very definite end date, and we knew what we had to do with the recyclable element, and therefore also the light as the service element. And I think, as Tim said earlier, recycling at the end of the life of the product is much easier if we've got all that data from the light management system. We know how what life is left in the LED board, what's left in the control gear, and the state of the luminaire, so we can reuse it ultimately, if we can, with a lot more knowledge, because we've got that data. So they all come hand in hand. So it is about designing the scheme properly, about having the lighting controls so we know what's going on in the scheme, and then having the luminaire at the end of it, but hopefully designed in this well thought out way in the first place, so that it is much easier to reuse at the end of that particular project life, and we can take it onto another project. And I think this is going to be the ultimate challenge for the lighting industry. Where do we find these projects? Because that is going to be the best use of luminaires that might have come out of a prestigious first project and then could be used somewhere else very happily. That's not quite so high level, you know.
Yeah.
And then we are going to have to go back to the recycle bit. You know, if we can't find a market for luminaires to reuse them, we've then got to move on to the next stage, take them back to the factory and refurbish them, which is all possible. We can do all this. We've actually done one project doing this, and the costs involved in it, the transportation, and then the non-uniformed way of refurbishing it, so it's not part of our normal production cycle, is very high in cost, and we have to find a way of making that much easier. And because I think it is going to become the norm, we're going to have to do it. So we have to put in new systems and processes to be able to do that.
Thanks, Helen. I'm afraid we're actually running a little bit over. I hadn't realised I was having such a good time, as I'm sure we all were. I would just like to put one final question to all of you, and I think this is a really good one from Richard Michael, and he says, do the panel think that a website similar to FreeCycle would work for the reuse of fittings that may be skipped following a refurbishment? So I'm sure you're all familiar with FreeCycle, but it's a community-based thing where people just post stuff that they've got that they don't need anymore, and they're not trying to sell it. There's no commercial aspect to it. What do you think about that? Steve, do you want to go first?
Yeah. I don't know how we make the mechanism work and whether it is to do with light as a service, but it's something we have to solve, because as an industry we are making light fittings that are going to last far longer than the typical high quality project that Helen and Tim and myself have talked about is going to need them for. You know, sort of 15 years down the line, there's going to be an awful lot of LED products that have still got a great deal of life left in them. So I don't know what the mechanism is. If it's partly light as a service becoming a norm in the industry, then brilliant, bring it on, because we need to do something with this light that's available and could be replacing much less efficient luminaires and light sources that abound. You know, it's a significant problem that we need to solve.
I think it's also going to be difficult going through all those other aspects of lighting that we have to consider, the safety and the warranties and all that sort of thing. So I see it more as maybe a band of qualified contractors or electricians that have the expertise to reuse these products in a safe way. So it's going to have to be a commercial thing, because people have to make a profit out of it. Now, whether it's something like Ricolite, that it's part of their recycling systems that they can resell a luminaire as is for second use, or whether we have to build up a sort of certification system where there's a qualified person that can say this is safe to use, and to make sure it's installed properly in the new project safely as well. And then you have got the problem with warranties. So it's not an easy solution.
That's a good point about safety.
I was just going to bring up the same thing as well, as Helen, about the safety. I think it's the first thing you need to be thinking about, making sure that people know, you know, one is there's a huge range of quality of products out there, as we all know today anyway, in the first instance, with products that maybe aren't, you know, the appropriate quality or safety in the first place, potentially. You know, how do you then manage that when products get sent for this reuse? I think understanding how the safety in that aspect can be, but of course about data understanding, you know, has the product got, how are we going to know what the distribution of the product is if you don't then link some way digitally the distribution curve to know how that product can then be used for future design. We don't just want to be putting lighting in for the sake of lighting. We need to make sure we're delivering the right lighting solution for the right application for the right lighting quality. So yeah, how do we get access to the LDT files, the data, the performance? You know, do we need to start monitoring not just driver lifetime, but also LED lifetime, almost putting a little mileometer onto the LED boards themselves, so we know, has it been burning for 5,000 hours, 20,000 hours, 100,000 hours? So if somebody is going to create this secondhand market or create this platform, they know what the performance is, what the life left is of that product, so we can, you know, do it in the right way. And I think it's a really interesting idea, but I think how it works in reality, I think, is maybe not as simple as maybe furniture, where you can see very tangibly what you've got. There's stuff going on inside it that you need to really think about. Fixing points, installation points, kits, all those different things that they need to be understood and make sure that they are safe.
It might be though that if we could get BIM working properly, you get a lot of that information. If you've got all that information in the BIM model, so that when you take something out of a building, that information comes along with it to the next use, and you have got all of that information about the fixing points and the depth, all the sizes and the LDT files, everything's there in the BIM data file. But I haven't seen BIM taking off in the way that it was originally explained to me.
No, I think it is, but I think it's something that would only apply for projects that are now being designed. So there's still an issue with legacy projects and there are still some small projects that don't fully utilize BIM. So yeah, that's an interesting point.
But I think you can, you can simplify it as well. For example, you can have QR codes in the back of products that you scan that takes you to that data and information. I guess it's BIM within a way, but it's maybe not within the Revit model or that side of things.
Physical.
Create data that does live online digitally, that has its information behind it, that has real value to that end user or the person who has that product who maybe wants to look to refurb it in the future. So I think there's other ways you can use digital means to do that.
Okay, well, I would love to keep talking about this, and I'm sure the audience would too, would love to hear more about this. I'm really sorry that we have to wrap it up, unfortunately. I just want to say thanks so much to our three speakers for their fantastic presentations. They've been really informative, so thanks a million. And thanks so much to all of you who've been listening in. And I'm very conscious that there's lots of questions here that we haven't been able to answer in the Q&A session. So we will get those questions to the panelists and they will respond in writing to you. And as I said, you can access a recording of today's session afterwards. You'll be sent a link to that. That's it really, and I very much look forward to seeing you again, although it won't be me chairing the next session, which is on the 21st of April at 11 AM, and that session will be focused on maximum comfort. So thanks a million, and enjoy the rest of your day. Thanks everyone.
Thank you. Thank you, Ruth. Bye-bye.
Thank you.